and the rest will be joining in.
Bien, buenas.
Good afternoon, everyone. In this fifth part of the tutorial I'm going to be giving you the softer concepts. The guys who know come after me. So, first clarification. Maybe some of you have met me already. I normally wear two hats. Many of you know me from the IXPs. Others know me because I work for a medium-sized operator, Eniplan, in Argentina. But I am a fan of peering in both cases, and I clarify this because I'll be as objective as possible, but I'm a true fan of peering and advocate of peering. So let us start with the content. First of all, we will be making a trip to the past to provide a context, and then we'll compare things with the current times. We'll speak about the basic schemes of interconnection, transit, and peering in order to later speak about costs conceptually, of course, and following that, we will speak about the IXPs, the role they play in the peering ecosystem, in addition to some other aspects that somehow or other can be considered collateral issues, can tend to demythify the theoretical world. We will be looking at topics related to transit and to peering because nothing is so clear-cut in real life. And then some conclusions. If we were to travel to the past, I would love to have 25 years less, October 9, 2005, and we'd go back to October the 9th, 2000. The images you have here are not my creation, but Gemini created these. So we would have an internet that is quite different compared to what we have today, topologically speaking, with a clear distinction in a stratified theme of tiers from tier 1 to tier 3, and basically found based on coverage. Those that had global coverage, because nobody could have totally global coverage, had a trend to have more peering connections. We will be explaining what peering and transit is in this community. I think there's no one in this room who really doesn't have a clear concept. But nevertheless, why was this so? This was in order to be totally global, but nobody really is. They looked for other peers that were reasonably global. So they looked for the convenience of saying, let us get interconnected, and this provides real global coverage. So that agreement was not particularly cumbersome, but it was a convenient thing. We provide the world with the appearance of a global coverage, and this was done through peering agreement. So this is the relationship between coverage and the number of peering agreements. Taken to the other extreme, ISP, which was the local one, and beyond vertical integrations between tier 1 and the ISP to reach the final customer, found a scheme that was mostly transit. So there was like a correlation here. This graph is an old slide. You have the source there. It showed that this is a simplified structure, but we can see the different strata. And I like to use this graph to explain some things.
Punteadas rojas.
One the dotted lines that symbolize the potential peering agreements, here exclusively in Tier 1. On the other hand, the content providers, and on purpose, we don't see the word that we have in the community, which are the content distribution networks, because these content providers were more distributed and connected to the major operators, and without this happening with the final customer, with transit agreements, which are the blue lines you have everywhere. And of course, there is something missing, which are the IXPs. It's not that the IXPs didn't exist back then. Cavase, in fact, created the first IXP in 1998, but there were not that many. Imagine today, in terms of IXPs in the region, we have more than 100 traffic exchange points. I don't recall the latest ones. So although in addition to that, these are concentrated in 2 IXPR projects and Cavase projects, we have more than 100 points where we can interconnect. Well, I don't know exactly how many there were back then in the year 2000, but that is why these are not relevant for the purpose of this diagram. So if we were to go back to the present and look how capricious Gemini is, I couldn't manage to put orange as I had in the first slide. So if we could come back to the present, conceptually, we would have something that would look like this. The peering agreement is something that is common. This is no longer the capacity of just a few or applied to the major ones, but this is something that anyone can have. And I couldn't modify this graph, this was like an image to put the IXPs in the middle. But please allow me to make some comments as to which things have changed. First of all, we have the IXPs that we don't see, and we'll explain how they intervened. Then we have the peering agreements all over, and maybe you cannot distinguish this very clearly, but let me show you where the cloud is. These are the content providers, so that is where the CDN concept appears. And these are no longer connected to the major ones, they're also connected to the smaller ones. I tried, but I didn't manage to do so. I tried to prepare a graph representing things much better as to how I view the current topology. It looks horrible, but anyway, I respected the colors of those who were in the previous graph, the sort of the bluish green, and the newer ones. The CDN at the bottom sort of disappeared, are included in that oval. The light blues and the red ones, the IXPs already existed, and it's then also, I don't know Akamai from what year it is, but I recall having contact with Akamai back in 2003 or something, and if it's not 2003, maybe 2005 or so.
But today, the issue of the CDNs is quite significant. So if you look at the actors, going back to the CDNs, in the May event 2010 in Curaçao, that was the first time I heard José Miguel Guzmán. I don't know if any of the old ones remembers speaking of the Google's CDN. That was the first time. So this, it wasn't so long ago that it existed. In the year 2000, it wasn't so common, and the same as ISPs the IXPs, there are hundreds in the region now. And although with these new players, it is difficult to see it in the chart, let me highlight some concepts. The one is the dotted lines, many peering agreements, but also with formats that are not as homogeneous as the topology that was presented in the first slide. Here, the heterogeneity is solved case by case, sort of. We may find ISPs that have CDN in their own facilities, or an IXP has the CDN in their own facilities, or the ISPs gathered in an IXP with a level of aggregation, they go and look for a CDN. So that homogeneity that you saw in the chart at the beginning is not so clear. And we also have different types of CDN. The content providers have their own CDNs, so there are CDNs that have multiple content providers, such as Laufer, Akamai, Laufer, etc. So the chart it's difficult to be able to represent it in a tidy manner, probably because I'm not creative enough. But we have many peerings with other actors that came to give that possibility, and with a flatter infrastructure. And although there are tier ones, although those of us who are old use that category, but I prefer to call it transit providers. And as I really wanted to flatten the infrastructure of the internet in the hands of peering. Well, so what changed for this to happen? Although the order you could think there's a cause-effect ratio, it's not so much so. So I put these arrows, but there's a no cause-effect relation. So it's full of ISPs. Something that was not so easy to access, that was doing peering with one or many, actually with many. Now we have that possibility, and it's massive. So in the past, in the year 2000, there were IXPs, but there were not too many. On the other hand, the other phenomenon that occurs is the concentration of the content providers. That is, in the past, it was more scattered. The content that we would consume was more atomized, many websites. But today, we have just a few content providers. If we were to list them here, we can count them. And I wouldn't say that one hand, the fingers in one hand is enough, but two hands would cover 70 to 80% of the traffic that circulates in the internet. That concentration of content providers causes some of them to have their own CDNs. This is not new for this community, because probably many of the meetings that are taking place outside in the hallway, or in May in the LAC Peering Forum. On the other hand, another thing that we cannot forget is the number of ISPs that have appeared. There are many more IXPs. So I was thinking, because of things that have nothing to do with this, I remember seeing the list of voters of LACNIC in 2017, 5,000 members. And last year, many more than 12,000. So you can say, they're not all ISPs. It is true, but there's a huge growth of ISPs in most of our countries. And I think that another element that we cannot neglect is availability of infrastructure. Maybe I should have put availability of infrastructure and the evolution of technology, because the truth is that fiber optic 25 years ago was not the same in terms of availability and cost. The access to technology, DWM, and the speeds available. Years ago, we would speak in terms of gigas for interconnections, and today the ONT of a network at home has a 1 giga port. So the infrastructure really has evolved. We build more, it's more easily available. And now it's easier to do things than 25 years ago. And as a consequence, what we have is a flatter, a more democratic plane. And I say more democratic because I think that peering is a form of democratizing the internet. What used to be the privilege of just a few turned into the quote unquote the right of the majorities. So let's see the different schemes of interconnection. I won't give you the details. What I want to do in this track is the softer part that has to do with convenience and with cost, with more commercial aspects. So I do not intend to teach you about peering, and less so in this of transit, and less so in this community. Transit, to tell you the truth, it has a couple of thumbs up when you look at it. With one single interconnection, it has an asterisk because you may say, well, in terms of quality, redundancy, I need this or that. Well, with one single interconnection, I can reach the world of the internet. That's good news for someone who's starting, who's small. It's the right way to do it. And I also think that although there may be cost schemes that are not variable, transit in general gets commercialized with varied costs. We pay per use, percentile 95, etc. So these are the thumbs up. Now we also have thumbs down. And these are the things that I see that are negative of only having transit. First, and maybe going back to the past, when the relation is too asymmetric, one of the two parties is the more powerful. And I witnessed a time when the peering was very little, the transit costs were very high, not just a few cents as today. Well, I would say that they were tenths, and I would say over $100. So, and basically that was because of the asymmetry we saw at the time. That's one thing. And on the other hand, and this also applies to the past maybe, the reality is that any access to any content would require multiple leaps, multiple hops. Today you can say, well, the transit provider gives me access to the CDNs, so this applies a little less. It is true, but anyways, as I defend peering, I highlight these thumbs up. I see that, well, if I have an access to peering with somebody, I'm accessing directly. So even if the transit is more direct than in the past, I prefer to have a direct access, at least if I see that it's economically convenient. And we also understand what a peering agreement is. The two parties need to agree that they want to exchange traffic, and then afterwards we'll see whether that implies costs or not. Somewhere I read that the peering agreement is like choosing your wedding partner. But the only difference is it's not monogamous. You can choose several, but both parties have to agree. And basically because there's a symmetry, because in a way the two of them recognize each other. But this coin also have other sides. If I want to reach many internet sites in the internet, I need many peering agreements. And this is going to be explained in the next slides. But when you interconnect with other, you are not giving them visibility of all the traffics. You are giving them visibility of your own traffic. So if you need to have connection to many things, you need a lot of connections. And on the other hand, and now we'll discuss costs, fixed cost, flat rates. Somebody has to pay for this infrastructure. And I have a peering agreement. It sounds very pretty, but somebody has to make the infrastructure available to make it feasible. And so if I use it very little, it doesn't make sense economically. It's not convenient. We're going to see this in the next charts, but I wanted to anticipate that at least with the thumbs up and thumbs down before we see the graphics. And this is not comprehensive, it's not exhaustive. This is just to expand our vocabulary. Peering can be classified considering different aspects. One is payment. Although I would say that mostly the peerings we see are free peerings, that is where nobody pays. Well, the real thing is, at least I don't have any records in my experience in Kawase and any plan of having any paid peering. But in the past it existed, and it has an asterisk because there are different formulas. I repeat, it's a two-party relation. They decided to exchange traffic with a mechanism different from transit, that is asymmetric, where one is selling to the other. In this case, it's different, but we have to agree who will pay more because the traffic may be asymmetric. So there used to be certain schemes. Now I don't know whether they continue to exist. In my experience today, it's not there. And also with respect on where the peering is done, it could be public or private. Usually when you speak of public peering, it's because it's done in the matrix of an IXP. And when it's private, it's because it's outside that matrix, and then it can be done inside or outside the IXP. And then the interconnection mode. This may apply better to the IXP. The peerings may be bilateral. In that matrix, you can choose between two to be interconnected, or you can adhere to the multilateral peering agreement, where all those who adhere may exchange the traffic freely. Certainly, there may be some more categories that I didn't include here, but just for the purpose of simplification, I put this to just cover the different dimensions. So let's see these very basic, I would say high school charts. The transit scheme is variable. So if you look at the total cost, basically it depends on the consumption. It might be a 95 percentile or whatever you agreed with the provider. The peering scheme, on the contrary, is if it's a free scheme where the parties are not being paid, the cost there has to do with paying for the infrastructure. And when I say that, paying the infrastructure, if I go and I do a plan for a peering plan against Google located in one of the data centers in Buenos Aires, for instance, certainly my plan is putting the fiber optic that reaches that data centers, the WM. If I buy the rack and I pay monthly, the cost in the is in the data center. And then we have the crusade of that, or crossing the rack to the racker to where Google is located. It could be Google or anybody else, just as an example. Or maybe we may ask Google to be in charge of that crossing. But in the end, each of us is somehow paying for that connection. The connection is not for free.
You might say, well, this is not a monthly payment. You invested in the fiber. So the amortization of this equipment is reflected in a monthly cost. But I imagine that most of you can understand the financial concept of amortization. So you imagine you paid this in several installments, which is life of the equipment. Why do I have these two graphs? Well, so I skipped one. Let me explain this, and then I'll go to the consequence of the two graphs. The two graphs at the top reflect exactly the same as the previous one, but they're flatter. But what we see over here is that if have a variable costs based on the bandwidth, the reality is that the individual cost, well, first there is an error over here. It says Mbps, but that's an error. And I continue speaking in concepts of megas because I'm old. I could have put gigas, but the reality is that the cost of a mega ends up being flat compared to what we have with peering. The more I use, then the cost per megabit will drop. If I have a peering agreement and I'm going to use the infrastructure I have only 10 to 20%, maybe it's not convenient to have a peering agreement. So what I need is to have a proper use of the infrastructure that I'm using, that I'm proposing for that agreement. And in case anyone is thinking about this is an oversimplification. What could occur over here? Well, of course, the transit cost based on the increase in bandwidth might tend to drop. Okay, yes, we could do something that is not linear. You might have a curve that becomes flatter. Or you might also say that once I reach a certain percentage of the peering capacity, you have to do an upgrade. Okay, yes, you could have a hop in the cost. So this is a simplification. But let us look at this graph, which at least theoretically, peering not always prevails over transit. No matter how enthusiastic we are over here, there are bandwidths, there are types of use that, at least from the standpoint of cost, transit could be more convenient. And once again, from a merely theoretical standpoint, the green curve shows the best cost scheme depending on the bandwidth that I'm going to use based on the costs as shown on this graph. Now, what is the aim of this? The aim is to achieve this. In other words, that the cost of peering is much cheaper and that intersection, regardless of my bias, I avoid having that crossing point, but I could place it more over here, for example. Then this is enabled by the traffic exchange point. Now, why did the curve go from the position in the previous graph move to this place down here? Well, this is because if I have an IXP, which I use to connect through one single infrastructure, and then I am at the IXP with several others with whom I can have a peering agreement, either because I joined the multilateral option or I have several bilateral agreements, or both of these, then the cost of the infrastructure is distributed over the number of peerings I'm doing. So ultimately, what we have here is the individual cost of each of these peerings. The IXP, to a certain extent, has been the enabler of the peering starting to grow massively, as we saw in the previous slides. So inevitably, we have to speak about the IXPs. This is a shared infrastructure that brings together all the players of the ecosystem of the internet, so we can come together and interconnect efficiently. And I say efficiently. I reach a place where they're all there. I go to buy things to the supermarket. So I'm not going to each, like when I was small, you went to the grocery store, you went to buy vegetables, to the butchers, and so on. Now you go to the supermarket and you pay parking. In the past, we went on foot. But the reality is that if you're all together in the same place, you can have multiple bilateral or multilateral agreements and make the most of that interconnection that we have. And the positive thing is that there are so many that go to that same place somehow or other, like we had seen in the graph that I tried to prepare with showing the new topology many slides backwards. Somehow this enables interconnection to the CDNs. This is part of the virtuous circle that we have seen over the past 10 to 15 years. I insist, back in 2010, we heard about Google mentioning these things, and those who witnessed the initial LAC peering forums that are different to the ones we have today, we were only beginning to speak about CDNs. The concept we used was, well, if we add traffic to the IXPs, this will attract the CDNs to the IXPs. When a CDN came, more members joined the IXP, and the more members in the IXP, we became even more attractive to other CDNs. And that is how this virtuous cycle occurred. So the graph that had only limited number of red lines for peering went to having many more. So it's about the chicken and the egg, but I think that the traffic exchange points plus ISPs and the traffic exchange points attract the first CDN, and that triggers everything. Inevitably, because in addition to being a fan of peering, I'm also a fan of IXP, I will be making an announcement with the dark side of the moon, the things that aren't normally seen about the IXPs, but not the dark side of the moon as something negative, but as something positive. The reality is that it integrates other members of the ecosystem. I'm speaking of the ISPs, but we're not only the ISPs. A colleague, I think it was from Costa Rica, went up to the microphone in the public forum and said, those of us who are ISPs should take into account other actors. And in fact, that is what happens with the IXPs. I'm not going to explain what a community is, because this here is a community. So if you come here, you should know what we are building. But the IXPs encourage the local community. What we're seeing here is something that we see at the IXPs. Quite obviously, we also help one another to develop the skills required, and we help one another to operate a changing business and poses challenges again and again. And we are catalyzers of the development of the internet at local level. And now, in a somewhat disorganized way, I would nevertheless like to refer to some of the topics that we have over here on the slide. Once again, I started out saying that I'm a fan of peering, but that is not always possible. And what are the reasons for this? Today, we might no longer see what we used to call free riding. I don't know if you remember what this is. If I decide to get interconnected to an operator, if I'm a local operator and I decide to get interconnected, to have a peering agreement with an operator that has a greater regional coverage, the reality is that that relationship will not be maintained normally. Now, basically, why? Because what the counterpart perceives, the one that developed a network throughout the country, is that I'm joining and connecting freely in order to reach the other end of the country, and the other one was the one who paid for it and has to amortize it. And this has somehow lost relevance, because the internet topology, instead of being interconnected operators, what we are is operators interconnected with content providers. So this led to flattening the internet topology. The concept of free riding, therefore, is no longer significant, but we should not lose sight of it. Let me give you an example. In the year 2000, we had at the Cavase IXP those that were considered tier 1. I say tier 2, but they had global coverage in the country. And it turned out that in 2004, they left. They decided that they were going to behave as a tier 1 and would not do peering with us. But I'm speaking of the past. I went back to the past, this 2004. And the argument is that of free riding. Today, this is less likely, and particularly because, once again, the relationship is no longer between operators, but is between an operator and a content provider, mostly. On the other hand, I'm not going to speak about fair share, but you, I'm sure, have heard about this at previous LACNIC meetings. One of the issues that is being discussed in this industry is this, because the telecom industry has dropping margins, very much saturated, high investments. So the telecom industry is becoming creative and wishes to create things that go against building a healthier and larger internet. But sometimes figures such as these are not in line with the theory that I am arguing in favor of peering. There are factors that are against peering. Some might say that the best way of promoting a good interconnection is through regulation. I encourage you to look up the results following 10 years of what happened in South Korea, where all this was regulated, and at the end of the day, what was regulated is that South Korea, compared to the other countries of that region, is the one where to manage local content, it is taken out of the country. So to go to the operator next door, I go outwards and come back. So this is a result of the regulation, and this is something that we have to agree on, that regulation is not the path, and probably regulation was not, well, it's very difficult to do regulation properly, so better not to do regulation. A couple of other topics that I'd like to touch upon. I think that, and well, this is a thought of my own. I think that what we know as content providers today have shifted focus. The major companies, the hyperscalers who are the content providers, in reality, glamour is in AI investigation and how they win that war. I honestly think that our world has lost the resources within those organizations. Many of you are now facing the situation in which caches that were virtuous in the past are not renewed in the ISP, or the small IXPs find it difficult to find the caches. Now the reality is that the aggregation capacity of the IXPs, which was the engine for all this to get started, now becomes once again relevant, at least in the established IXPs. If we gather a lot of members, this makes it feasible to the CDNs to come and renew their caches. Finally, the competition of IP transit. A while ago, I said that any of us might be paying, I think I paid invoices of $150 for 100 megas, and today we just pay a couple of cents for a megabit. Transit competes sometimes with peering. They want to pay at the crossing points of the original curves, and this also occurs. It's not bad that this happens. I like transit to drop, but I realize that sometimes we have to balance the short versus the long term. In the short term, I might say I pay less, I do no peering no more, but I must not forget that there was an asymmetric relationship, and based on that asymmetric relationship, the ISP was at a loss. To finish, these are the conclusions. I think that peering is a fundamental part of the new interconnection schemes. And when I say new, it's not today. This is what happened in the past 25 years. We have to be guardians. It optimizes the variables of cost and quality simultaneously, and we have to continue working in this direction. I think the IXPs and CDNs are an engine that make this virtuous cycle reach the stage it is now. And we have to maintain these points, and we have to be guardians thereof. With this, I would like to close. Thank you very much.
Gracias.
Thank you, Hernan. Thank you for your presentation. Well, the truth is that with everything you mentioned, mine is going to be much faster. I can shorten it. Could you put my presentation, Guillermo Sicileo, definitions, peering? It's not there. Okay. There it is. Importance of the traffic IXPs. Let me talk. Well, I'm going to talk a bit about this. Hernan mentioned it, but I wanted to reinforce it because it was a change. He mentioned how the internet was, what the internet was like a few years ago, and what it is like now. Now we have these networks where we have the users connected and we have the content somewhere else. Usually it's somewhere else. How did that work? How was the traffic routed? Well, usually the end users are connected to a provider, an access provider, and that provider provides access and has a contract with a transit provider to reach other sites. You have the cloud with interconnected autonomous systems, and through another transit provider, the content provider reached the rest of the internet. So users would look for the content somewhere. It could be centralized somewhere and be replicated, but mostly that was the search. Going through the different internet providers. So if the content provider had to expand those linkages, the traffic with the transit provider, with the rest of the network, possibly the ISPs also have to expand them. So, well, we all had to expand that. So as the content grows, and this and others, the ISP has to expand the transit provider too, depending on whether it's local or it has enough capacity. Well, the idea is that the links grow.
¿Cuál fue la alternativa?
So what was the alternative that the content providers started seeing? Well, get closer to users and not paying providers, transit providers, but rather reaching either the ISPs or the IXPs. And we've even seen in recent years how the content providers have deployed fiber, intercontinental fibers, the ocean and the continents, from one continent to the other. That's a significant change we've seen. The content will no longer be sought in a data center centralized somewhere, but the content is closer and closer to the end user. It's there locally in the borders of the network. So that is the important change that we've seen. So Hernan already mentioned the peering. He mentioned the complexity. When we have many peering links, well, if you have to stretch these peering with all the autonomous systems, that is why we have the public interconnections where the operators may connect either in a data center or through an IXP. So, well, let me skip this because Hernan mentioned it too. These issues, for instance, the cost of transit and the cost of, well, an IP transit and transportation. In transit, we pay per megabit, more or less fixed. And in the case of transportation, we have a fixed capacity. The more we use it, the less we're going to be paying for bandwidth per megabit. So the more efficient, if your contract includes 100 gigas and we use only one, the cost is going to be very high. We'll pay 100 and we'll use one. But if we use 150, it's going to be much more efficient. And while in the IP change, we are always going to be paying more if we pay for capacity. The IXPs, Hernan mentioned this too, but basically this is a site where the operators get interconnected. It's a shared infrastructure to exchange traffic, and we have the IXPs, but also the contents providers and other content sites such as universities, media, banks, etc. So these are sets of autonomous systems that get interconnected. An IXP is not an access network. It doesn't give access to the end users, but the operators connected to it do that, nor does it usually provide IP transit. It's also done by the operators. It's not the mission of the IXP. It may be the case in some cases, but usually these are separated cases. And with regard the advantages, it has many technical advantages, including that the traffic is routed locally, so you can have less latency for the applications, and that is sort of what they were looking for in the slides at the beginning, when we saw that the content shifted to the border of the network where the users are. So one of the things that we aim at is to reduce latencies. Apps like gaming that need to reduce latencies. It makes a big difference if a provider is on the edge and you're playing against somebody in another continent. The same for the financial operations, for the fintech, where you're trading. The faster you do things, the better. And obviously, the costs change when you have to do a local interconnection and not with international. We talked about the CDNs. The traffic usually remains inside a country. It doesn't leave, or at least within a region. And also, the length of they may be 1 or 2 hops, so the interference goes down. On Monday, when we talked about hijacking, usually for hijacking to take place, we need to have several autonomous systems intervening, because there are 2 interconnected. One usually won't hijack the other. So from that point of view, it's also more efficient, or it's better. But, well, this last thing in the sense of community, that it happens because, well, around the IXPs there are groups of operators that share problems and solutions. So as the IXPs get older, after working many years, they see it more, and the technical groups that exchange experiences get consolidated. In the case of Cavase, this has been the case for a long time. And they discuss things that are technical and not technical, with regulations and things that may affect the operators. Basically, an IXP is more as this sense. Here there needs to be redundancy. And the important thing is here, basically we have a switch or an architecture layer 2, where the routers of the operators connect. When we want to have connections where we don't have to connect each operator with all the rest. But if we have something like a route reflector, we may have a route server. A route server is a server that typically gets connected to the same switch architecture, and through that system, some of the autonomous systems, or all of them, may BGP with some route server instead of a BGP, of having to establish a BGP connection with each of the other autonomous systems. So you can do a BGP correction directly between the autonomous systems and the root server, and the root server publishes those routes to the rest of the operators. So what is the important thing about route servers is that they give several advantages in terms of security and filters, because when the members of the IXPs publish the routes, the route server may apply strategies including filtering of filters, filtering things like the bogans that should not be published in the IXP. It prevents route leaks. They can filter through RPKI and to implement filters like RPKI and IRR and WHOIS, etc., so as to sort of clear the routes. Today in the region, the IXP manager is mostly used. There are a couple of route servers per software. IXP manager was installed in many of the IXPs in the region. The route server also allows to discuss bilateral policy. Everything the route server receives, they forward it to the rest. Hernan mentioned this. And finally, I leave you some references on these issues, the campus, these tutorials, and some references about a route server and BGP. I don't know whether you have any questions. I think it's about time. It's break time. Thank you. After the break, we'll resume with more technical topics. I didn't introduce them. I'm Guillermo Sicileo of LACNIC, Nicolas Antoniello of ICANN, Erika Vega, and Ariel Wechner. Well, we'll resume after the break. We'll discuss these topics.